Hello, my name is Mariel, and I am a graduate student in water resources science here at the University of Minnesota. My pronouns are they, them, and today I'm going to be sharing a little bit about my research on Minnesota wetland watersheds. So a little bit about wetlands. Wetlands are a big part of our ecosystems here in Minnesota. They span the majority of the upper part of the state near the North Woods, and they're particularly important for regulating flow through watersheds. So a watershed, as you might be familiar, is the land area where any rainfall that falls over that area runs out through the same stream or river. So with wetlands, these systems are able to contain a lot more water and buffer large rain and flooding events that we've been seeing in increasing frequency over the last couple of years. Some other properties of wetlands that you might be less familiar with, they're also important for filtering out contaminants. They provide critical wildlife habitats, and one of the characteristics that I focus on the most is their ability to release and store carbon. So wetlands are actually responsible for storing almost a third of the world's soil carbon. And the way that they regulate this is through their hydrology, and particularly their water table. So what I do is look at the way that these wetland systems are changing because of climate change. And the sites that I work at are actually just north of Grand Rapids, Minnesota, and are part of a long-term ecological research site called the Marcel Experimental Forest. Really cool place. If you're ever in the area, I recommend you check it out. And I work at two bog sites. So bogs are a subset of wetlands where we've been witnessing decreasing trends in water table elevation. And this decrease can actually cause increases in methane emissions, which then generate this negative feedback cycle within the atmosphere. So our questions have been to look at why this is happening, and we focus specifically on the winter and spring seasons because snow and the amount of snow melt are so important here in Minnesota to determining water recharge and overall water availability during the spring and summer. And so it turns out that when we do our analysis, which I'm not going to outline here, we find that soil frost is a key ingredient in determining the amount of our snowmelt that goes into the soil and recharges the water table versus what runs it directly off into streams. And so this division is what we call partitioning. So as climate change is happening, we're seeing warmer winters, which lead to less snowfall and slightly denser snowpacks, which the snowpack generally insulates the soil layer below it. So large snowpacks cause smaller layers of soil frost, which allow for more recharge and less runoff. Whereas smaller snowpacks actually increase the amount of soil frost, and so we see less recharge and more runoff. And so we're still working a little bit on supporting these hypotheses with data, but these sorts of relationships are really helpful for understanding the effects that climate change has on wetland carbon balances and overall ecosystem function. So that's just a little bit of insight into what I do. If you have any more questions, feel free to shoot me an email. I'd be happy to talk. Thank you so much for listening. Bye for now.